English for everybody. Yes. Okay, Lars Erhardsson. I'm working at Scania since 2001. Always in the paint business and surface treatment, starting at materials technology first, and then moving on to purchasing, and then exploring the suppliers world. And then I started to work at the Global Industrial Engineering in 2019, so under Lars Henrik Jörning's group. And today I've been asked to make a presentation about Scania and the surface treatment we have and the paint shops we have. So I will try to give you an overview of our paint shops, the bigger ones, and what kind of activities we have been doing since we built them, because you build a paint shop and then it lives for 15-20 years, but it's continuous improvements. So that's one of the lead words for Scania. So content looks like this. I will give you a short overview of Scania with some fun facts, and then we go to the chassis paint shops, the axle paint shops, the paint shop in Oskarshamn for the cabs, and the paint shop in Möppel for plastics. And try to summarize with some future steps, and hopefully it matches a little bit with what you presented, Charlotte. Hopefully. But Scania in brief. We have been here since 1891 in Södertälje. If you took the tour yesterday, he explained how the nice history was, but we are a global, 100 plus companies, 56,000 employed. We are 17,000 in Södertälje. So we are bigger than Astra now in Södertälje. That's good. Yeah, the product is of course trucks, but we can build a lot of different trucks. So it's only when you start working for a truck company that you start to notice which type of brands and which type of trucks there are on the road. So before starting at Scania, then you was just annoyed that, yeah, it's a truck, I need to pass it. But it's trucks, buses, we have special purpose vehicles like fire trucks, military trucks, and then we have power solution with engines. And I think this one gives an overview of the volumes we are producing. We are not the biggest producer, but we focus to be on the premium brand instead of high volume. And then power solution is it's industrial engines for power generation, for example, or water or fire protection engines, or marine engines. We are famous for our modular system in the business, and the modular system is based on that we can combine different engines, gearboxes, batteries, and now it's batteries also, frames and axles to configure the vehicle so it fits the purpose for every customer. And with this modular system, we can also decrease the number of parts that we have in the portfolio. That's also a way of being sustainable. Our production looks like this globally. So in Luleå, we have the chassis, the frame painting. Then in Södertälje, Zwolle and Angers, we have the final assembly. In Oskarshamn, we are doing the cab. And in Meppel in Netherlands, we are doing all the plastic parts. So I think the pictures of the cab and the plastic parts is quite illustrative that the add-on parts is as big as the cab actually. So we say that the cab is about 75 square meters to paint, and the plastic is also about 75. In Poland, we are doing buses. In Brazil, we have what do you call it? Another hub. And we are planning to build a third hub for total production in Jiangsu in China. So that's a big project at the moment. You know about it. Sustainability at Scania. Now I will make a mess of myself since we have our sustainability channel, but I think we are it's super important, and we focus on two areas. One is the sustainable transport issue, where we are making a lot of effort for the product, working with the energy efficiency, preparing the engines for or the battery vehicles for renewable fuels and electrification. But we also have the responsible business for the society. So here we are working with our environmental footprint, working with people, and how do we engage in society to become a sustainable company. So it's not only the product. And I think the new thing for us that Lars-Henrik also explained yesterday, that we are in the start, it's working with circular business. And I think we have received a lot of good ideas. We have, of course, ambition and targets, and I highlight here the CO2 emission targets. And I checked during the last presentation that if we look at Oskarshamn, the cab factory, we are spending 60% of the energy used for the whole plant is used for the paint shop and the complete area. And I think for wastewater, I think it's 40% or something. It's a lot. But to help us in this work, we have this 7 environmental principle that everybody is educated in at Scania. So we focus on energy, water, chemicals, waste, emission to air, and impact on our local surroundings. And when it comes to painting and surface treatment, all these are targeted. So that's a good thing. So now I will jump to our plant in Luleå. We are doing the frames and the cross members there. It's a hot rolled steel that is blasted. It's let's see. So we are doing this frame part, and we are doing also the rear axle bridge that is sent then to Södertälje. And all these parts are then sent to the chassis plants in Svolde, Södertälje, and Alger. And we have 2 painting lines where we are doing degreasing, we are doing grit blasting because it's the hot rolled steel. And then we have a zinc phosphate pretreatment, an electrodip coating, we have an electric ovens for this, for the curing of it, and then powder painting, and then oven again. And something that is special for Luleå is that we have both the electric oven, and that was a strategic decision from the beginning when they built the factory, that they have local supply of electricity from the water plants. And the infrared booster oven was also built because they didn't have space. So then they decided very early to have an infrared oven.
And was there from the beginning, or was it after?
No, also beginning from the, yeah. So I don't know, the old line, the cross, no, it's wrong. The side member line has the infrared booster oven. I don't know how old it is now, but we got a new paint line in 2015 when it was burnt down. It was big news. A lot of engagement from Scania, but with this newer line, we got a new storage to separate everything, secure it more for fire, and we got a new wastewater treatment installation also. But performed actions here is that Luleå invested a lot of time in R&D in the grit blasting. I think it's easy just to throw steel grits on the parts and then it's fine, but they have been exploring the type of grit, the exchange rate, and try to adapt quality and process control to the number of square meters that they are treating. And they also had this, what do you call it, ampere monitoring of the engine doing this grit blasting, so they can directly detect if the ampere is going down, then it's not really throwing stones, for example. So they try to improve to get better control of the process. With the new line, they got the 3-step rinsing instead of 2, and then they are saving water. So that was state of the art at that time. But they have also frequency control of the pumps. in general on all pumps to have operational mode and resting mode. And they also implemented automatic dosing of the ED binder based on the square meters. And from this, they find also a very stable process. And one advantage with the infrared booster for the powder oven is that it's short, but they also see that they get a better finish compared to the other line that doesn't have this infrared booster. And they think that the infrared is heating the substrate instead of heating from surface to substrate. Axle and maybe not the engine paint jobs. We are painting our assembled axles with the primer and top coat. It's a waterborne system here in Södertälje. We have a power wash cleaning in this one. But maybe special is high pressure painting. And that we also installed a limestone system from ABB when we built this paint shop in 2006 or 5 or something. It's still standing, and it's what's very early using community heating. And we have a high temperature system from the community heating also. So we are using 110 degrees for the ovens and the 70 degrees for ventilation and workshop ventilation. And they have also been working and improving. So quite early they introduced this winter and summer mode together with the paint supplier. So we adapted, instead of keeping plus minus 5% of relative humidity, they adapted it to winter season and summer season. And by this they could reduce the cooling capacity or the need for cooling, for example. They introduced demand-driven ventilation quite recently, and I think they're doing that at several, because there is a manual station after the automatic boxes where we do touch-up and some custom adaptations. We have installed an automatic program for start and stop of the process, so in between shifts and weekends. And they are actually stopping the process before the shift ends. So they are using the residue heat, for example, in the ovens for the last period of the shift. And they bought a new cooling machine now, and then the heat recovery system is included. And I think this is a result of we're updating we call it PAPE, the purchase. Yeah, it's the process we use for procurement of process equipment. And in this, we updated it with the energy checklist. What do we call it? Checklist for energy.
It's energy efficiency.
Energy efficiency, exactly. So it was a huge step for you, I think, or for us, that we have it already in the purchase process, that we focus on energy. We got rid of some biocides by installing UV lamps in the humidifier installation, and it also decreased bacteria and decreased maintenance a lot. And they also installed a support heating system, because the paint shop heating system, the paint shop ventilation and the workshop ventilation was connected. So for the paint shop to operate, the workshop also need to operate. So they actually installed some heat pumps to be able to run the paint shop, but not the workshop. And then they also included LEDs and zone classifications for that type of saving. We jump to Oskarshamn. It looks like this. It's a very elongated picture. But here we have pretreatment, zinc phosphate. Maybe special is 2-cat ion, since so we got rid of mangan very early. And then we have the powder primer that is kind of special in this industry, and with a new line. And then we have PVC sealing, top coats, We have both waterborne top coats, we have solvent-borne top coats, and then anti-corrosion. And here we have worked with, we have green electricity, and that's standard for all production units that we have at Scania. So that has been introduced, but they have also changed to RME fuel for the burners, for the ovens, because we have diesel burners for heating the ovens. So to become sustainable, quick, and CO2 neutral here, they changed to RME, paying a lot more, but it's worth it. And then we also, and it's really working. And for internal trucks working on diesel, we also use HVO. So Oskarshamn is claiming to be CO2 neutral when it comes to the energy resources, and they also have city heating. In '94 we introduced the powder primer, and the gain we have from this one is a lot of. It's a single layer, it's working both as primer and filler primer, and it's a high material usage in this one. The downdraft is maybe the what do you call it? Surface defects that we have to struggle with sometime, with cratering and etc. So it's ups and downs. We changed the cavity wax to an air drying, so then we took away an oven a couple of years ago. And with the new paint distribution, I'm not really sure about the details here, but you managed to optimize it so we could reduce the rinsing waste with 50%. And we also adjusted some of the ventilation there. So a lot of the CO2 emissions comes from what type of energy we are using, so doing smart things. Then we have the plastic paint shop in Meppel. I think this is the latest one we built in 2006. It's up for refurbishment, and we built a new primer paint shop in connection to the top coat line, and it was finished last year and started up. Meppel is the plastic paint shop is painting all these colored parts on the truck, as you see, and it's a lot of square meters. But they worked with this in this factory. They are working with high visibility, so you should see all the equipment. So if you have a leakage or if you have a disturbance in somewhere, the operators walking around it should see it. It should be visible. So that's the mindset here. Also, the new primer paint shop is a gas-free installation. The top coat line is running completely on gas, but they installed a heat pump system with a cooler on the roof and are producing their own water. So it's a circular system with electrical heating and heat pump system to create hot water and cold water for cooling and for maintenance. And for the ovens, they have a separate electrical heating system at 110 degrees instead. And it's a low temperature since we're painting plastic. They install an electrical VOC oxidizer, electrical RTO, that is operating in this new primer paint shop. And it was at that time when they built it, was the biggest one in Europe for this supply. Very efficient. It says a lot of kilowatts there, but when it starts up and running, it's auto, what do you call it? Automate. When it's up and running in this temperature, it's auto oxidizing. It's not using the electricity, it's just using the VOC. Dry filter system. We see a lot of advantage in this one. And also some when it comes to blow off operations in the power wash, they've seen that they are using fans, but it's also a good example of instead of using compressed air for blowing, that you can use the fan blowers instead. And Meppel in Holland, they made a deal with some cement industry in Holland to reuse the carbon filter from them. So, what's the time? Oh, 5 minutes. Where are we going? We can still improve. And I borrowed this triangle that we have a reduce, reuse, renewable way of thinking. And I think there are many steps we can do further to reduce with investments. We just need to prioritize. But we see that the film pretreatments that we have been working with a lot now and hopefully can start implementing in our production is giving a lot of benefits when it comes to sustainability. For process control, we see that dosing per square meter is also giving a lot of good effects, and that will also be implemented if we do go for thin film treatments. It also gives a good quality effect, but it also gives less waste, less chemicals, optimized use of the chemicals. I think we will continue to challenge the ventilation settings. We look into brownfield installation to exchange this water venturi system that we have for collecting paint waste, overspray waste. Or we could do like the engine paint shop is doing, that they have reduced the overspray to 5% only with wet paint. Yeah, some of us saw that yesterday. We're also investigating if we can replace all the inspection lighting. And we have these big lighting tunnels for daylight with artificial daylight. And traditionally it's been tube lights, but now we want to go to LED lights instead to have a big saving. A lot of kilowatts, and every tube light is like 58 watt. But if you add 40, 50 of those tube lights, then it's a lot of effect. Low temperature curing of powder paints for our paint shop in Luleå. That's also one item that we want to introduce, but it sounds easy. But we have a lot of demands on it's a technical demands on the powder because when we do the assembly of the chassis, we don't want it to relax in the joints because everything is painted before we do the assembly. So then the paint is part of the design. And I think we need to be better in digital simulation to optimize. And I think we do a lot of saving, maybe not in time, but we do a lot of saving in trial and error in production. And we're also looking for CO2 snow cleaning for the axle paint shop in China. And it's not super efficient. It's not as efficient as the power wash, but it's more economic. It doesn't use water, and we are working backwards in the change to look on the cleanliness instead. Maybe moving the greasing station after the paint shop instead of before the paint shop as we have today. And also in China, they are looking for the building, not insulation, but insulation. So in reuse, we have some work to do with this closed loop system for water. We are behind you from Volvo. And we will also look for recircling the rinse liquids. There we have been using recircling of the rinse for the waterborne system in Oskarshamn for many years, but not the solvent-borne. But here we are also trying to make progress in Sweden. Recovery system, heat exchanger, that will be quite common in the future for all investments. Another topic could be to, instead of burning the VOC, maybe we can reuse it. Recover H2. And implement vision system for finish. I think that's also, it's a sustainability for the workers, more or less. But you get a better working environment, and you don't have to do this repetitive work. And renewable, we have plans for, and we have solar plants. We are discussing local biogas production with a plant in China. Bio-based rinsing agent is a project that is ongoing for us, and I think we need to be prepared for multi-fuel and maybe diverse sources for heating. So we can use district heating, and we can top it up with the power, with the electrical heaters, or we can maybe have gas heater, biogas heaters. So think a little bit like we do for the truck, that we can use any fuel. So that's a taste from Scania.
Questions to Lars? You said 60% of the energy is from the surface treatment. Do you reuse the heat from the ovens to something to heat the buildings or so? Or
I think the ovens it's recirculated in the ovens.
Yeah.
It's also topping up, but I guess you're using it somewhere.
Yeah, there's
Yeah.
And also should also maybe also comment that 60%, and that is also we. I mean, we have a press shop on the site. We have a big body shop with a lot of welding equipment. So that also is energy consuming. So still the paint shop is quite a big part.
Yes.
Still a lot to do.
Yeah, exactly.
That's good.
Yeah, it's good for us.
So this was the session surface treatment. So now it's lunchtime. You want to stay?